Welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming all my grade 9 elite math students to yet another video on my channel. This is on module 10, lesson 4, exponential equations. And our learning objective in today's session would be to solve exponential equations by using the power property of equality. So let's dive into the video and see what we are learning today. So first of all, you need to know what is an exponential equation. So an equation in which the independent variable is an exponent. So for example, you have base 2 to the power x. So x here is the independent variable. So if you have an equation which involves 2 to the power x equal to say something like 8, for example. So this becomes an example of an exponential equation. So exponential equation is an equation in which the independent variable is an exponent. So it's in the power, that is variable x here. So there is a property which is a key concept for today, power property of equality. We are going to use this property for solving all the questions in today's video. The property says that if b is a positive number and not equal to 1, then b to the power x is equal to b to the power y. This happens if and only if x equal to y. That means if the bases are equal and the powers are different, however the two exponents are equal, then this happens if and only if x equal to y, means the powers are also equal. And this holds true conversely also, that if x is equal to y, then b to the power x will become equal to b to the power y. Let's take some examples. The first example here, 4 to the power x equal to 4 to the power 5. Now if you see, the base is same, both sides it is 4, so the power has to be equal, so x will be equal to 5. Let's look at another example, n equal to 2 by 3. So if x is equal to y this way, then its exponent 5 to the power n will also be equal to 5 to the power 2 by 5. So both ways it is true. Another example, if x to the power 1 by 2 is equal to 3 to the power 1 by 2, you see the powers are equal, then the bases are also equal, so x will be 3. So this is an application of power property of equality. Let's now use it for solving questions. The first question that we are solving here is a one-step exponential equation. Now to solve this, you have to make the bases equal. You see the base here is 3, but the base here is not 3. So let's do the prime factorization. It is always a key, skill of solving any question on exponents. So when you divide 243 by 3, what you get is 81. Then you divide it by 3, you get 27. Again divide by 3, you get 9. Again by 3, you get 3. And finally you get 1. So 243 can be written as 3 to the power, let's count, 1, 2, 3, 4, 5. 3 to the power 5. So I can replace this 243 with 3 to the power 5 is equal to 3 to the power x. Now can we apply power property? Let's check the bases. Yes, the bases are equal. Both are 3. So the powers will also be equal. So x is 5. This is how you solve the one-step exponential equation using the power property of equality. Now let's see how to solve a multi-step exponential equation. Definitely, because it's a multi-step, there are going to be many steps that will be there to solve an exponential equation. So here the equation is 227 to the power x minus 1 equal to 3. So which is the lower base? The base lower, which is less in number, is 3. So that means we have to convert 27 into the same base into 3. So how can you write 27? It is 3 to the power 3. So you replace 27 with 3 to the power 3 and solve it. So multiply the powers. 3 multiplied with x minus 1 gives 3 to the power 3x minus 3 equal to 3 to the power 1. Now we can apply the power property of equality. You see the bases are same, so the power will also be same. So 3x minus 3 will be 1. Solve this equation for x and it will come out to be 4 divided by 3. So that's a multi-step exponential equation. Let's solve another multi-step exponential equation. Here if you see, the base is 256, the base is 2. So let's reduce to base 2, which is the simplest base possible. So we are going to do again prime factorization of 256. Why we are doing it? So that we can reduce it to a base which is base 2. So we are dividing 64, again 2, 32, again 2, 16, 2, 8, 2, 4, 2, and finally 2, 2, 1. So this is how many times 2? 1, 2, 3, 4, 5, 6, 7, 8. So 256 is 2 to the power 8. Let's replace here. So 2 to the power 8, and there is always x minus 2 also, this one. So 2 to the power 8 times x minus 2 is equal to 2 to the power 2. Now can I apply power property of equality? The base is same, so yes, the power becomes same, so these are also going to be equal. So I can write 8x minus 2 equal to 2. Let's multiply using distributive. 8x minus 16 is 2. Solve for x, that's what we need. So this is 18. So x is 18 divided by 8. If you divide it with 2, this comes out to be 9 by 4. So x equal to 9 by 4. This is a fractional power or a rational power of x. Let's solve some more exponential equations. So here we are going to be solving question 7 and question 8. Okay, so let's solve, and then 9 and 10 you will solve yourself. So 3 to the power x minus 3, and by now you have understood that we have to write the big numbers as the same base which is given here. So we are going to do again prime factorization of 243. So we are going to do it with 3. So this is 81, again 3, 27, 3, 9, 3, 3, and 1. So 1, 2, 3, 4, 5, 3 to the power 5. Now bases are same, so powers will also be same. So x minus 3 is equal to 5, or x is 3 plus 5, which is 8. So that's your answer for question 7. Let's do now answer for question 8. Here we need to do prime factorization of 1024. Now when we are doing prime factorization of 1024, if we do it with 2, it will become very long. So we are going to do 1024 with 4. Reason being, because the base here is 4, so we can just directly do with 4. So when we do, it comes out to be 256. Again you divide by 4, it is 64, again by 4 it is 16, again by 4 it is 1. So if you see how many times, 1, 2, 3, 4, 5. So 4 to the power x minus 1 is 4 to the power 5. Now the bases are same, both are 4. So the powers are also same. So x minus 1 equal to 5, or x equal to 5 plus 1, which is 6. So x equal to 6 is the final answer for question 8. That's how you solve. So do the prime factorization of 1296, get your answer of 9. For question 10, same prime factorization is going to work for you. So you will be getting 4 to the power 2x plus 1 is equal to 4 to the power 5. That means you will just equate 2x plus 1 equal to 5 and get your x for question 10. Let's solve this equation. It's a multi-step equation. The base here is 2, the base here is 2048. So we need to do prime factorization of the big number, which is 2048. Let's do it with 2 only, because 2 is the base here. So when you do, it will be 1024, again 2. So it will be 512, again 2. So it will be 256, again 2. So it will be 128, again 2, so it will be 64, 2, 32, 2, 16, 2, 8, 2, 4, 2, 2, and 1. So big prime factorization: 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times. So 2 to the power 4x plus 3 is equal to 2 to the power 11. Bases are same, so powers have to be same. So 4x plus 3 has to be equal to 11. Let's solve. 3 goes on the other side. 11 minus 3, so 4x equal to 8, or x is 2 here. Similarly, do the prime factorization of 6561 divided by 3 and get your answer for question 12. Let's solve some more questions. These are quite easy because if you see, the base here is 9, the base here is 81, and you know 81 is 9 square. So that's what I'm going to put here. So it becomes 9 to the power 2 times 2x minus 3 equal to 9 to the power x plus 3. Now the bases are same, both are 9, so the powers have to be equal. Let's solve for x from here. So 2 to the power 2x minus 3 is equal to x plus 3, multiply, and this is 4x minus 6. Take this to the other side, so minus x minus 3 is 0. So 3x minus 9 is 0, or x equal to 9 divided by 3, which is 3. So the answer is x equal to 3. Now sometimes we also get negative exponents, like question 19. Let's solve it. So for question 19, if you see, you are given 16 to the power x equal to 1 by 2. Now 1 by 2 can be written as 2 to the power minus 1. And here 16 can be reduced as 2 to the power 4, so that both sides bases are equal. So now if you see, the base here and the base here both are 2. So the powers 4x equal to minus 1 will be equal, or x is minus 1 by 4. So that's a negative exponent. Similarly, for this question, you will get a negative exponent. Solve question 21 to 25 yourself and put your answers in the comment section for me to check. Let's do a word problem. In the 1950s, scientists proposed a space station that could house a crew of approximately 80 people. The space station could produce artificial gravity by rotating at a speed of W equal to square root of GR. So this is the formula we are going to use, where G is given to be 32 feet per squared. R is the radius of the station. If the station design required a rotating speed of approximately 64 feet per second, that's given to you to stimulate gravity on Earth, what would the radius need to be? So if you see this equation, there are three variables, W, G, and R. G is already given to you, 32 feet per second square. R is what you need to find, and W is given to be the rotating speed, which is 64 feet per second. So let's write the unit also. So these values are given, so just we need to put it in this formula. So 64 is equal to square root of 32 R. From here you need to solve for R. So let's go to the next slide and solve this exponential equation using the power property of equality. Okay, so the radical equation that you had got after substitution in the last slide was this. Now you can convert the radical equation 32 square root r into exponential as 32 r to the power 1 by 2. Now if you convert in this form, 64 can be written as 8 square. Now look at the bases. The base here is 8, the base here is 32. They're not same. Even the powers. The power here is 2, the power here is 1 by 2. Not same. So how can we make the power same? Let's make it same by writing 2 as 4 divided by 2. When we do that, we are able to write 8 to the power 4 multiplied with 1 by 2. Now, are the powers same? 1 by 2, 1 by 2? Yes. So power property of equality would say that the inside base is also equal. So if I may just quickly highlight with yellow, this base 8 to the power 4 will be equal to 32R. So when both are equal, you can expand. 88 to the power 4 is 4098, which is equal to 32. Divide by 32 both sides, and the radius is 128 approximately. So that's how the word problem can be solved using exponential equation. So that brings us to the end of today's session. If you liked this video and found it useful for understanding exponential equation, give it a thumbs up, share it with your friends who will benefit from it, and don't forget to subscribe to the channel and also press the bell icon to receive notification of all my upcoming videos. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.